All right, let's talk about Java design patterns. We're going to dive into some really powerful insights from a talk by the one and only Venkat Subramaniam. And look, if you've ever felt kind of boxed in by the right way to use patterns, you're going to want to stick around for this. So, you know how we're all taught that design patterns are basically the holy grail of good software design? Well, what if that's not quite right? What if our obsession with using patterns is actually a trap that can lead us to write code that's way more complicated than it needs to be?
Okay, wow, that is a very bold statement from Subramaniam. I mean, the Gang of Ford book is practically required reading for developers. But his point isn't that the book is bad. His point is that it accidentally created this mindset where developers started treating patterns like a to-do list, something you have to check off, instead of what they were meant to be, a guide.
He uses this fantastic analogy of grandma's pie. Think about it. You can get her exact word-for-word recipe, follow every single step, and your pie still comes out, well, terrible. Why? Because grandma isn't just following a recipe. She's using intuition. She feels when it's right. The recipe is just her way of describing what she already knows how to do. And that's exactly what design patterns should be.
So if patterns aren't a recipe you start with, then what in the world are they for? The big mental shift here is to see them as a tool, a really powerful tool for communication.
This right here. This completely reframes everything. Patterns are not your starting point. They are the vocabulary you use after you've wrestled with a problem and figured out a clean solution. It's how you talk to your team. It's being able to say, hey, you know that thing I built? It's basically the strategy pattern. See? You don't start there, you arrive there.
I love this analogy. Imagine you're in a drawing app. You don't sit there and carefully trace the grid lines, right? No! You just start drawing your shape, and when it gets close enough, it just snaps to the grid. It makes everything clean and aligned. Patterns should be like that for your code. They provide that final bit of structure as your solution takes shape.
Okay, enough theory. Let's look at some real, concrete examples of how modern Java has made some of these old, kind of clunky patterns feel completely natural and, well, fluent.
Ah yes, the dreaded null pointer exception. We've all been there. Returning null is just a bad smell in your code because it creates so much uncertainty. You're never sure if you're getting a value back or not. Optional fixes this so beautifully. It makes it explicit in the method signature that a value might be missing, forcing you to deal with it. It turns a runtime bomb into a safe compile time check. For decades, we wrote for loops. We were manually controlling every single step of the iteration. Getting the iterator, checking if there's a next item, getting the item. It's all very focused on the how. The Stream API completely flips this. Now we have these elegant, readable pipelines. You just declare what you want to do. Filter this, map that, collect the results. The language takes care of the how. It's a huge improvement.
Now this one is a real game changer. The classic strategy pattern. Man, it was so much work. You had to create an interface, then a bunch of separate classes to implement it, maybe a factory to wire it all up. It was a whole production. And today, you just pass a Lambda. That's it. A block of code becomes just another argument to a method. It's the exact same pattern, but it's so lightweight now that it's just a natural part of the language.
But, and this is a really big but, all this new functional power comes with a critical responsibility. If you're going to use streams and lambdas, you absolutely have to understand the concept of purity.
One of the absolute biggest dangers in this new world is something called shared mutability. This is what happens when your nice, clean-looking stream pipeline secretly reaches outside of itself and starts messing with a variable or a list that lives somewhere else. It completely breaks the rules of functional programming and leads to code that's totally unpredictable and a nightmare to debug.
Subramaniam tells this perfect cautionary tale. There's a developer. Their code works flawlessly. One day they think, hey, let's make this faster. So they change one single word. .stream becomes .parallelstream. And suddenly, chaos. The code starts giving wildly incorrect results. And why? Because that pipeline wasn't pure. It was secretly mutating a shared list. And as soon as it ran in parallel, all those threads started stepping on each other's toes.
This just perfectly captures the shift in thinking you need. With impure functional code, especially when it's running in parallel, you can't really say it works anymore. You can only say it behaves. It does something. But you can't guarantee it's the right thing every time, and that is a terrifying place to be as a developer. So, how do we stay out of that terrifying place? It all comes down to these two simple rules for purity. Number one,
Your function doesn't change anything outside of itself. No side effects. That's the one we usually think of. But number 2 is just as important. Your function doesn't depend on anything from the outside world that might change while it's running. You need both for your code to be correct and safe.
And this all brings us to the most important, the most crucial takeaway of all. We need to refocus our goal as developers. It's not about the pattern. It's always about the problem.
And here it is. This is the ultimate goal. As languages like Java get better and more expressive, they start to absorb these patterns. The strategy pattern didn't vanish. It just got so easy to do with Lambdas that we don't even think of it as a pattern anymore. It's just a feature of the language. The whole point of a great language is to make elegant solutions feel natural, not like you're following some complex ceremonial blueprint.
So we'll leave you with this. This is the one critical question you should ask yourself every single time you sit down to write code. Are you laser-focused on solving the actual business problem in front of you? Or are you just looking for a nail because you happen to be holding a hammer called design patterns? The answer to that question really does make all the difference.